Hey guys, I'm going to work on going through the Meteorology Lab review for you. So we'll be making a key together. The very first three questions all have to do with October 1st and calculating the incoming solar radiation or figuring out the latitude of the noon sun. In order to answer these, we need to figure out where the sun is on October 1st. So I'm going to scroll down, and here's my analemma. Not quite the same as the one in your lab, but still I can find October 1st right about here, and I can read over. We're 3 degrees and we are south of the equator. So the answer for the very first one is 3 degrees south. Now I'm going to use that to answer the rest of my questions. For question number 2, I have to use the same formula. 90-degree angle of the sun, and then we have the difference between the sun's angle and your angle. Okay, so I'm not even sure if that helps because that's little pictures, but it should jog your memory because you've used this formula before. So for example, for A, we have 90 degrees minus the difference between 80 degrees north and 3 degrees south. Since they're in different hemispheres, we're going to add them together. And what we get is 7 degrees. We would do the same thing for the next question. 90 degrees minus 40 plus 3. And you're going to get 45 degrees. So you have a 45-degree angle. So about half that of 3 degrees south. Now, at the equator, for question C, you're just going to do 90 degrees minus 3. Probably don't even need to write it out. 90 degrees minus 3 gives you 87-degree angle. So it's a really high angle, means very direct sun. It would be a good idea to wear sunscreen on that day. Now for the next set, we're dealing with southern hemisphere for D, E, and F. For these ones, we're not going to subtract, not going to add, instead we're going to subtract. So for example, for D, we'll do 90 degrees minus the difference between 30 degrees south and 3 degrees south. So 90 minus 27, and we get 63 degrees. We'll do the same for the next two. 90 degrees minus 65 minus 3 gives you 28. And then for the very last one, 90 degrees minus 3 is going to give you 3 degrees. This is an extremely low sun angle at the South Pole on October 1st. The next question, number 3, says, what would your latitude be if the sun angle is 55 degrees to the south on October 1st? So you kind of work backwards on this one. We have the 90-degree angle that the sun's making, but this time the sun is 55 degrees to your south, and we know it's in the southern hemisphere. So we know the sun's in the south, so you must be in the north looking at it. So we're going to add those two together, and what we end up getting is 32 degrees north. So that's the answer. And if we wanted to maybe figure that out on the Earth, if that's the equator right there, we know that the sun is shining just above 3 degrees, or just below the equator at 3 degrees south. You have to look 55 degrees away, so your latitude is going to be this 32 degrees north that we figured out. So it all checks out. Okay, the next set of questions have to do with drawing the Earth and how the sun would be in relationship on October 1st. So you're supposed to draw and label several things. I always find that it's easiest to draw the sun in first, and I like to have the sun on the right. You could put it on the other side if you want. So there's my sun. What this means is that I can go directly perpendicular, and that gives me my circle of illumination. So I just shaded in the night side to illustrate the circle of illumination. Now I'm going to go ahead and I'm going to draw in the axis. For the axis, we would want to tilt it so that the sun is shining a little bit to the south of the equator. So I'm just going to have a 3-degree tilt here from the sun in the northern hemisphere. And that's kind of hard. I mean, that's almost straight up and down. Your goal is to have your axis go right through the center point between where the sun is and where the circle of illumination is. So I'm going to do my best to draw a straight line here. Pretty good. Put in some north and south just to keep track of what I'm talking about. Now, the equator is pretty easy to do. If you have a protractor, you're just making a perpendicular line. So that's my equator. The Tropic of Cancer is 23 degrees north. The Tropic of Capricorn, 23 degrees south. The Arctic, 66 north. And the Antarctic, 66 south. So I have the equator, the tropics, Antarctic, Arctic, they're all there. You notice everybody gets a little sun or a lot of sun. Everybody gets a little night or a lot of night. So nobody has 24 hours at this point. Because remember, not too long ago we had the equinox where everybody got equal 12 hours a day, 12 hours of night. So now we're moving into fall for us, spring for the southern hemisphere. Okay, so this is the one that people found probably the most challenging out of the 3 exercises. We're given quite a bit of information here. Temperature at sea level, 35 C, relative humidity, 14.5. We're supposed to figure out the dew point before we even start. The dry rate's 10, the wet rate is 5. That's constant. These two right here, they're constant. I shouldn't even have to give them to you, but I do because it's usually given to meteorologists. So there you go. All right, so we are given the information that the temperature is 35 degrees at sea level. We're supposed to figure out what the dew point. So we have to switch over and figure out how much it can hold. So I'm going to go to table 14.2. All right, so I'm looking at table 14.2. I find 35 degrees and I read straight over. Oh, 35 can hold 35. But our 35 degrees is at 14.5% relative humidity. So this is not the answer for dew points. And I'm not going to divide it by 14.5. Instead, what I'm going to do is I'm going to say, okay, 35 grams per kilogram times 0.145 for my relative humidity equals 5 degrees. Or sorry, 5 grams per kilogram. So if I go up until I get to the 5, then I read over, now I have my dew point. So this 5 degrees, that's the dew point that I'm going to take back to the other side. So just to recap, 35 degrees holds 35 grams per kilogram. If we figure out what 14.5% of that is, we get 5 grams per kilogram, which is saturation for 5 degrees C. So that right there is my dew point. So I'm going to write that 5 degrees C. Now, at sea level, I have 35 degrees for my temperature, 5 degrees for my dew points. I'm going to use the dry rate because they're not the same. So I'm going to subtract 10 from the 35 as I go up 1,000 meters, but I'm going to keep the dew point the same because it hasn't been reached yet. I'm going to keep doing that, subtracting by 5 as I go, until I reach a point where they're the same. So now at 3,000 meters, I have reached what is known as the condensation level. Clouds have formed, the two are the same, saturation's occurred. So I used the dry rate that whole time. I never changed the dew point, but the temperature dropped by 10 because it cooled down as it went up in the atmosphere. From here on up, I'm going to use the wet rates, just subtracting 5 from both. So I have 0 and 0 and -5 and -5. So that's my summit. Some of you didn't know what a summit was the other day. The summit's the top, the base is the bottom. So moving our way back down, we've got the same dew point the whole way. So I can go through and I can put that -5 all the way down because the dew point's not going to change. But the temperature is going to, again, use the dry rate, but this time we're adding. Before we were subtracting. So instead of -5, we're going to add 10. So we'll have 5, 15, 25, 35. Finally at the base, 45 degrees. So we started off with 35 degrees and a dew point temperature of 5. We're ending with 45 degrees and a dew point temperature of -5 degrees. So let's think about this a little. How much can -5 degrees hold? -5 degrees isn't really on the chart, but it can hold about 3 grams per kilogram. Now remember, that was the same temperature that we had at the top. So at the summit, we were holding about 3 grams. We started off with 5 grams. If you look in this original calculation, I said, okay, if you're 14.5% saturated, you're holding 5 grams. So if we started off with 5 grams down here, and up here, all we had were 3 grams, well, the difference between them is 2. So 2 grams came out as rain. Totally just realized that I made bloody rain. So let me fix that real quick. Now it's blue, that's better. So we got 2 grams of precipitation for every kilogram of air. Temperature at the top, -5. Temperature at the base, 45. So we've had an extreme temperature change. You definitely want to wear layers as you're doing this hike so that you could add or subtract as necessary. Make sure you bring a lot of water so you don't dehydrate. Take some pictures at the top because it should be good. And, send me a postcard. So I think you've got the review down here. We've done all 3 parts. I've gone through it, shown you how to calculate it. There's several other questions you can ask yourself regarding this mountain, and maybe you want to do that for practice. Otherwise, as long as you can do this when you come to class on Monday, I will be happy.